Hello everyone, I am Sandralyn Rodam, and in this video, I am going to tackle the proteins and the amino acid. Mostly of the makeup of the amino acids and of the processes of forming a protein. Now, we all know that our bodies are made up of different protein types. May it be from our muscles, in our bones, in our hair, in our eyes, eyebrows, nose, mouth, and even as I stand up today, you are seeing that I am made up of different proteins. It is a recurring pattern of knowledge that our bodies are made up of proteins, and the building blocks of proteins are the amino acids. The questions though are, how did these amino acids form? What are its contents? And how did this amino acid form into our proteins that we are seeing today, and how did this function?
There are actually 5 major objectives to be met in this video.
The first is to know the structure of the amino acids. The second is to know the forces that maintain the structure of the proteins. And the third is the primary structure of the proteins. The fourth is to know the secondary structure of the proteins. And the fifth and the last is to know the tertiary structure of a protein. As previously mentioned, the building blocks of a protein is the amino acids. There are 20 amino acids known throughout. Now, these amino acids are classified into two. They are non-polar, or the hydrophobic, and the polar, which are the hydrophilic. Polar or hydrophilic amino acids are subdivided into 3 classes, which are the neutral amino acids, the positively charged amino acids, and the negatively charged amino acids.
The amino acids are actually classified and categorized according to their side chains.
There are actually 3 important makeups of an amino acid that makes it important to become a structure. The first is the amino group, or the N-terminal. The second is the carboxyl group, or the C-terminal. And then the third is the alpha carbon, which contains the side chains, which differs from an amino acid to another amino acid. In this example, I chose to portray the glycine. So, peptides. Peptides are 2 or more amino acid that is bonded through peptide bond to form a protein. A peptide can either be a dipeptide, a bonding between 2 amino acids, a tripeptide, a bonding between 3 amino acids, or the polypeptide, which contains 3 to more amino acids. The structure of an amino acid doesn't really change when bonding to another amino acid. In fact, the carboxyl group and the amino group bond together for a peptide to be possible. For example, the glycine and the alanine. As I had go on with the lesson, I found a simpler way in describing the structure of a protein. It made me think of the concept of folding, because folding becomes more complicated as time goes by, like the protein of structure. It reminds me of folding and origami. So let's start it off with the primary structure. Primary structure is a linear structure of the multiple amino groups forming peptides. Primary structure is like a clean slate of a paper before starting to fold.
In the formation of the secondary structure, a force such as a hydrogen bond plays a role in maintaining the secondary structure of proteins. Previously, with the primary structure, amino group and carboxylic group are the mediating factor to connect an amino acid to another. Because of this, hydrogen bonds are formed that enable the protein structure to have its folding, which is either alpha helix or beta sheet. Alpha helix is the most common structure of proteins. They are the structures that provides covering such as the hair, walls, fur, and nails. It also has its spiral structure and its arch chains that are located outer of the structure. All of the amide, hydrogen, and carbonyl bonds are included in hydrogen bonding except the first and the last. The beta pleated sheet, on the other hand, reminds me of the fold of the pleats of the skirt that I wore during high school and elementary. In beta sheet, all amide hydrogen and carbonyl bonds are included in hydrogen bonding, thus resulting to the pleats-like structure formed. It also has two orientation, the parallel or the head-to-head and the anti-parallel which is head-to-tail.
The tertiary structure is more complicated than all the structures mentioned. It has a three-dimensional structure. Its structure are maintained through multiple molecular forces such as the van der Waals forces, the hydrogen bond between the polar R groups, the covalent bond, and the salt bridges that form due to the disulfide bond. Thank you for watching this video. Once again, I am Sandra Radam, a BS nursing student at Biliran Province State University.